Hi, today we're going to be talking about some rules regarding polarization. So the rule is if central atom, if central atom has all surrounding atoms are the same, it's nonpolar. If central atom basically means if there is a central atom, if all surrounding atoms are the same, it's nonpolar. If they're not the same, it's polar. Alright, that's kind of obvious. Alright, here, all surrounding atoms the same, it's polar. Now, second one, if no central atom, symmetrical equal nonpolar. Asymmetrical equal polar. Alright, these are basically the rules. Alright, so not what I mean by no central atom is basically if you have like a C and a C, then since these are symmetrical, they're obviously nonpolar. Now, if you have something like H and N, you can see that it's not symmetrical. One's H and one's N, so this is polar. This is polar, and the previous double C one, double O, double everything will be nonpolar. And now, if there is a central atom, let's say, I'm doing so much examples, like CF4, right? C in the middle, F, 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 F. Alright, this will be nonpolar since all the elements around it are the same. And here's the thing: if there are dipoles, it would be polar, except when dipoles cancel out. So in the previous video, we talked about how when dipoles don't cancel out, it's polar. But I'm going to show you what it means by dipoles canceling out. So let's go back to the example we did a few videos ago in the ICL4. ICL4, if you remember, is I in the middle, Cl, Cl, Cl. Let me see if I can memorize it. I can. Alright, Cl has a charge 7 times 5, 45. And I'm pretty sure it's ICL minus, so 46. Alright, so 2, 4, 6, 8. Oops, 36. Alright, there. Now, alright, this is right. Alright, now this is 36. And also, one more thing. If you're feeling lazy to type, write all these CLs, all these dots, what you can do is write lines instead. One line means 2 dots. So these two mean the same thing. And basically, if you don't want to write all these dots, you can write this, except when you're dealing with CL, because when you're doing CL, it makes it seem like you're doing CLL, and sometimes it gets confusing and stuff like that. So for CL, it's best to keep it as dots, but for everything else, you can feel free to change all the dots into lines. Two dots form one line, but do not do that on lone pairs. Lone pairs need to be dots itself. Alright, so now there's two lone pairs. That means although all the surrounding elements are the same, there's 2 lone pairs, and this means it's polar because dipoles do not cancel. Alright, but if we have something like I3 minus, I3 minus 3I. Oh, don't forget the bracket. Alright, if we have something like I3 minus, it's going to be I in the middle and I and I. Alright, so I has 3. 3 times 7 is 24. 21 plus 1, 22. So I has 3 times 7, 21, 22. Now 1, 2, 3, 4, 5. Actually, I'm going to just draw lines to show you. 1, 2, 3, 4. Alright, plus a giant bracket minus. Alright, so now so now this, although all the surrounding atoms are the same, But another thing that you take notice is the lone pairs. 1, 2, 3. 3 total lone pairs. Now, 3 lone pairs is the maximum a central atom can have. So this basically means that all the dipoles cancel each other out. When you see something like this means dipoles cancel each other out. And this one will be non-polar. Why? Because all surrounding atoms are the same and dipoles cancel. This is something to take notice. Make sure when you see one lone pair and two lone pairs, you know obviously that it's a polar. That's straightforward. There might be some exceptions, but I haven't learned that yet. So for now, just know that most of the times one lone pair and two lone pair are polar. And if you have something like 3 lone pair, all the dipoles cancel each other out. Your explanation will be it's non-polar because all surrounding atoms are the same and dipoles cancel each other out. If the surrounding atoms are not the same, then it's obviously polar with no doubt. So these are the rules that you need to know and be careful of when you're doing polar, when you're figuring out if a compound is polar or non-polar. Thank you for watching.